Hey everybody, what is happening? Well, we talked a little bit about acids and bases last video, and we talked about the fact that compounds that are acidic have a pH from 0 to 7, and compounds that are basic are from 7 to 14. And acids have an H plus ion, and bases have an OH negative ion. All right? So we're going to look a little bit deeper into acids and bases. And acids can usually be recognized by their chemical formulas. They can either have an H written at the beginning of the formula, like HCl, or hydrochloric acid, or the H is written at the end of the formula if the acid contains the element carbon. There's some rules for this. And there's an example here. Acetic acid is acetate plus an H plus ion, and it's written at the end because it's got carbon in it. Now you'll usually see the abbreviation AQ. Well, if we see this written after an acid, it means that it's short for aqueous, which means that it's dissolved in water, kind of like Gatorade powder. Next, we have some examples of some common acids. So take a look at the formula on the left-hand side. And you'll notice that we've got HF, so that's hydrogen fluorine. We name it, and it's hydrogen fluoride. You'll notice we've got the "ide" there. And then the name of the acid, so the name you'd see on like a package would be hydrofluoric acid. It's used for glass etching and manufacturing aluminum and uranium. We've also got hydrochloric acid, which is made out of hydrogen and chloride, or chlorine. And you'll notice we have an ick on that. Now this is stomach acid, this is in us, and it's also used for manufacturing plastics. Next we have HClO4, which is hydrogen chlorate, and you would see that on a package, it would be chloric acid. All right, and this is used for air pollution control. Very interesting. Next we've got HClO2, which is hydrogen chlorite, and we've got this on the back of a package would be chloris acid. Now this is used to kill germs and viruses, so we would put this stuff in cleaners, in things that say 99.9% of all bacteria is killed. We've also got hydrogen hypochlorite, and that would be called hypochlorous acid. And if anybody has a swimming pool, that's what your mom or dad would put in there. Now there's some really cool things here is that you'll notice the endings of the chemical and the acid formulas are in bold. Now if a substance names end in "ide" or "ate", the acid will have an "ic" ending, and you can see that in the patterns above. Now if the substance names ends in "ite", it will have an "ous" ending, hence right here, hypochlorous acid. Notice when we have an "ite", we use an "ite" or an "ate", we take off the hydrogen part. Next we've got bases. Now bases can usually be recognized by the OH at the end of their chemical formulas. And our most common one is NaOH, which is sodium hydroxide. And that's right down here. So we have sodium hydroxide. There's nothing special for naming bases. We just name the metal and we put hydroxide at the end. So NaOH is drain cleaner. This would be like Drano. And you don't want to drink that. That's very basic, very caustic. It destroys proteins, which is pretty cool. We use it to manufacture paper, glass, and soap. Next, we've got magnesium hydroxide, and this is the active ingredient antacid. So if we know that OH minus is going to cancel out H plus ions. That's pretty cool. So if you take some of those, milk of magnesia or magnesium hydroxide, it's going to stop with the acid in your stomach or neutralize it. Next we've got ammonium hydroxide, and this is kitchen cleaner. It's also used to make fertilizers. So if we turn the page, we're going to be talking a little bit about the production of ions. So this is really important because we need to be able to know if something is acidic or basic. Now we can test it with pH, we can test it with a pH meter, and we can also go and use a bunch of different indicators, and we're going to get practice at this in class. And you can refer back to your data booklet And these are the different indicators that you would be using to test if something's basic or acidic. So a solution that is either basic or acidic is able to conduct electricity because it contains free-moving electrons. All right. Now, when acids are dissolved in water, they produce H plus ions, and when bases are dissolved in water, they produce OH negative ions. Now, the more H ions that something has, the more acidic it's going to be, and the more OH ions something has, the more basic it's going to be. And you can see this in the continuum right here. So we've got neutral right here, and then acidity this way, and basicity there to the right. And you'll notice as we go down the pH scale, we get more and more H plus ions. And you'll notice right in the middle that when they're equal, we have the same number of H plus and OH negative ions. And this gives us water. When these things combine, they produce water. Now, if we want to stop something from being acidic, we can add a base to it. And this is called neutralization. So in many cases, the acid and base cancel each other out and they will become neutral. So let's look at a few of the different characteristics or properties of acids and bases. So remember, we never test anything in the lab by tasting it or touching it. We're going to use devices or indicators to test it because it could really hurt us. So you know that acids taste sour. So this would be things like a lemon or a lime. And we contrast that to bases taste bitter. So that's if you were to eat some soap. Now, acids may burn you, and bases feel slippery. Now, they may also burn your skin if they're too strong, and sometimes bases that are very reactive are called caustic. Now, going back to acids, acids turn blue litmus paper red, and bases turn red litmus paper blue. Now, acids corrode or break down metals, and particularly magnesium and zinc, and bases do not corrode metals. So corrodes break down. They both conduct electricity when they're in an aqueous solution, so that means when they're both dissolved. The pH for an acid is less than 7, and a pH for a base is greater than 7. And finally, acids form H plus ions when dissolved in water, whereas bases or produce OH negative ions. All right, have a good rest of the day.